Hello, and welcome to another exciting episode of Managerial Economics Problems Solved. So today we got a request, thank you so much for the request, for a solution to a Cournot equilibrium problem. So I'm going to go ahead and use this simple example. It's got some nice numbers, but I ensure you that this applies to all sorts of different types of Cournot equilibrium problems. So we're given a price here that is reflective of the total quantity, right? This is our total quantity for the whole market, which is made up of Q1 and Q2. We're told that the individual costs are 40 times however many output they end up selling. And so in order to figure out our Q star, right? So we're asked for our Q star. Well, where is our Q star? It's where the marginal revenue is equal to the marginal cost, right? So we'll go ahead and just put this in a little box up here. So in order to figure out what our marginal revenue is, well, we need to figure out our total revenue first, right? So we know that our total revenue is going to be whatever that market price is times the quantity for whatever firm it is. So let's just go ahead and say firm 1. We're going to do firm 1 right now. And so we know that the price is represented by 100 minus Q. Now let's go ahead and let's simplify this one more time before we go ahead and put that in. So this price is going to be 100 minus, and then in parentheses, Q1 plus Q2, which ends up being P equals 100 minus Q1 minus Q2. So don't forget to distribute that negative sign to that second term in the parentheses there. So now that we have the price, now we can go ahead and substitute that into here. So we end up with total revenue is equal to, open parentheses, 100 minus Q1 minus Q2 times, and then this big Q1 is the same as just a little Q1, so let's go ahead and just keep all the stuff consistent. We're going to go ahead and distribute this to all three of the terms. So we end up with a total revenue for firm 1 that's equal to 100 Q1 minus Q1 squared minus Q1 times Q2. And then from here, it is a matter of taking the first derivative, right? Getting that marginal revenue for the total revenue is how much does my total revenue change given a change in my marginal revenue. And so the partial derivative with respect to Q1 means that if I have something that's to Q1 to the first power, it just ends up being whatever that number is that is multiplied by it. We're going to use the power rule for this one. So we pull this 2 down. It ends up being negative 2. And then it's Q1 to the 2 minus 1 power, right? Which is just the 1 power. And honestly, we can just get rid of that completely. And then minus, so since it's the partial derivative, it's just going to be whatever. We're going to treat this Q2 like it's a constant. So this is just going to be minus Q2 because this is Q1 to the 1. So anytime we have a to the first power in the total revenue, when we take the marginal revenue or the partial derivative, it's just going to end up being whatever that is multiplied to it. So this is the marginal revenue for our first firm. And so what do we know? We know that we're going to set the marginal revenue equal to the marginal cost in order to find our optimal Q star, right? So let's go ahead and figure out our marginal cost here. So our marginal cost is going to equal the partial derivative of our total cost with respect to whatever our quantity is. And so it's just going to be that constant 40, since this is Q to the first power. So our marginal cost is going to be just a constant 40. And so when we set those equal to each other, and then we solve, we end up with this, 100 minus 2Q1 minus Q2 is equal to 40. Now, I bet you're saying to yourself, Dr. McCarthy, we've got one equation, 2 unknowns here. How can we solve? Well, we actually can't completely solve just yet, but what we can do is we can isolate Q1. So since this is our marginal revenue for firm 1 and our marginal cost for firm 1, we're going to want to have Q1 on one side of the equation. And so what I'm going to do is I'm going to add 2Q1 to both sides. So then I end up with 100 minus Q2 equals 40 plus 2Q1. I'm now going to subtract 40 from both sides. So this ends up being 60 minus Q2 is equal to 2Q1. And then I'm going to divide everything by 2. When I divide everything by 2, both of these terms get divided by 2. So 60 divided by 2 is 30 minus 1/2 Q2. And that is all equal to Q1. And so this is our Q1 star, right? Because that's where the marginal revenue equals the marginal cost for that firm 1. So this we also know as our reaction function in terms of Q2. So you also might see it expressed this way. Now, for the sake of abbreviating time, I am not going to do the same thing for firm 2 because of symmetry. Okay, so firm 2 has exactly the same cost, it has exactly the same market price, and so as a result, we know that if this is firm 1's reaction function, then firm 2's reaction function, which is in terms of Q1, is going to be 30 minus 1/2. We can literally just switch the Q1 and the Q2 in order to get our optimal reaction function there. Now, if you want to do a little extra practice, I implore you to go ahead and do the same process on your own again for firm 2, but I promise you it's going to give you the exact same answer. Now, from here, now we have 2 equations and 2 unknowns. Which means that what we can solve for both Q1 and Q2, and specifically the optimal Q1 and the optimal Q2. Well, how are we going to do that? Well, we are quite simply going to just substitute one of these into the other. So we're going to substitute our Q2 into our Q1. So our Q1 ends up being 30 minus 1/2, open parentheses, 30 minus 1/2 Q1 equal to Q1 star. And so now from here, it's just a matter of properly distributing things and grouping things. So we end up with 30 minus 15 plus 1/4 Q1 is equal to Q1 star. So this ends up being 30 minus 15 is what? 15. And this ends up being, you just add 1/4. You can pretend that this is 4/4. So this ends up being 4/4 plus, or sorry, minus, excuse me. This ends up being positive. So that's what I get for skipping a step. So here we go. Let's go ahead and go back a second. So this ends up being 15. And then we're going to minus 1/4 Q1 from both sides. This is going to annihilate itself. We end up with just 15 on the left-hand side, and we end up with 3/4 Q1 on the right-hand side. Now, how do we get rid of 3/4? We multiply both sides by the inverse, 4/3. And 15 times 4/3 gives us 20, if I am correct. Let me double check here. Yes, excellent. So you can check that on your own. Now, the next thing that we're going to do, since we know that that is the Q1, we can know again by symmetry that Q2 star is also 20, right? They have the same exact reaction function, and so they are going to solve for the same exact optimal quantity. Now, the next part of the problem is probably going to ask, well, what is the profit then that each of these firms are making? So in order to figure that out, we need to get the price. So we know that the price is equal to 100 minus Q1 minus Q2. And we know that Q1 and Q2 are what, 20 apiece? So the price is going to be 100 minus 40, and so it's going to be $60. Finding our profit is just a simple matter of taking total revenue and subtracting total cost. Total revenue is going to be 60 times 20 minus 40 times 20, or, since these are common elements, we can pull those out, and it ends up being 20 squared, or $400. All right, I hope that helped. If you guys have any questions, please feel free to email me. I'll be uploading one on the Stackelberg oligopoly problem tomorrow, so stay tuned for that.